Welcome to Geometers to today's video, which is an algebra review. Today we are reviewing solving systems of equations. So before we jump into our examples, I just want to review what does it mean to solve a system. So anytime you're solving a system, you have two or more equations. So the first meaning, and this is an algebraic meaning, is you're finding the solution that works for all equations. So you're finding the points that work in all of the equations. So that's algebraically. Thinking geometrically, all of the equations that we're going to be looking at are lines. So when you solve a system, you're finding the intersection point of the lines. Okay, and so these two are going to relate to each other, especially when we get down towards those last two examples. This should be something that you have already learned before in algebra, so we're only going to do a few examples. Looking at example 1, it says solve by substitution. Okay, with substitution, you always want to solve for one of the variables. So you want to get either x equals or y equals. In this case, we already have x equals. So in our second equation, anywhere that there's an x, we're instead going to write 3y plus 4. So we're going to have 2, instead of x, we're going to do 3y plus 4 plus 6y equals 12. So again, I wrote this second equation, instead of writing x, I wrote 3y plus 4. Now I'm going to distribute this 2. So I have 6y add 8 plus 6y equals 12. 6y and 6y are going to give me 12y plus 8 equals 12. If I subtract 8, I get 12y equals 4. So y equals 4 over 12. I can simplify this. Both 4 and 12 are divisible by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So right now I have y equals 1/3. Now I need to solve for x. Hopefully you remember you can use either equation. But my first equation is already x equals, so that's the one I'm going to use. It's x equals 3y plus 4. This is helpful because I'm looking for x. So x is 3 times 1/3 plus 4. Okay, simplifying from here, I have 3 times 1 over 3, so 3 is like 3 over 1, plus 4. 3 times 1 and 3 times 3 is 3 over 3 plus 4. 3 over 3 is 1, so 1 plus 4 gives me x equals 5. So my solution now is 5, 1/3. This is the only point that will work in both equations, and it's the intersection point of those two lines. Now, to check our answer, all we have to do is substitute that answer back in to both equations, not just one, both of them. So I always like you to check. Okay, checking the first equation. I have 5 equals 3 times 1/3 plus 4. So I have 5 equals 1 plus 4. That works. My second equation, I have 2 times 5 plus 6 times 1/3 equals 12. 2 times 5 is 10. 6 times 1/3, that's 6 over 1 times 1 over 3. So this becomes 6 over 3, which is 2. So I have 10 plus 2 equals 12. That works out. Your solution should work in both equations. If it doesn't work in one of the equations, it means that you did something wrong. Okay, so this was an example where we already have x equals or y equals. Let's look at the next example where we don't have x equals or y equals. Okay, so here's example 2. I told you that for substitution, we always want to have x equals or y equals. That was easy with the last example because we had x equals. In this case, we don't. X and y are on the same side for both equations. So looking at that first equation, the x plus y equals 3, we can solve for x or y though. Now, because the last example had x equals, I'm going to solve for y on this example. So I'm going to subtract x, I get y equals 3 minus x. Okay, now I'm ready to substitute. Now, this equation right here is from the first equation. So I want to substitute for y in the second equation. So I'm going to have 2x minus 3. Now I'm ready for y. 3 minus x equals negative 14. Now the question is, am I going to distribute a positive 3 or a negative 3? Well, with subtraction, I like to change this to adding a negative. So you want to distribute a negative 3 in this case. So I have 2x plus negative 9 plus 3x equals negative 14. 2x and 3x will give me 5x minus 9 equals negative 14. Add 9, I get 5x equals negative 5, so x equals negative 1. Now, to find y, I'm going to substitute into either the first equation or the second equation. Looks like the first equation might be a little bit easier, so that's the one I'm going to use. My first equation is x plus y equals 3, so I have negative 1 plus y equals 3. If I add 1 to both sides, I get y equals 4. So my solution is x, negative 1, comma y, 4. Now, it's really easy to check our answer, so just please check your answer. It's silly to get an answer wrong if you can check it. So our first equation, x plus y, negative 1 plus 4, does that equal 3? Well, yes, it does. That was an easy check. Second one, 2x, so 2 times negative 1 minus 3 times 4 equals negative 14. So this becomes negative 2 minus 12 equals negative 14, which also checks out. Okay, so negative 1 comma 4 is the only point that works in both equations, and it's the point of intersection of the two lines. So that was a review of the first solving method, which was substitution. You also did linear combination or elimination. So that's what we're going to do for examples 3 and 4. With linear combination or elimination, you want to match up the numbers in front of one of the variables with the same number but opposite signs. So opposite signs, if we look at n, we have negative n and positive n. So we already have opposite signs. Now I want the numbers in front to match. So the first equation I have a negative 1n. The second equation I have positive 2. In order for them to match, I'm going to have to multiply the top equation by 2. So I get 4m minus 2n equals negative 2. My second equation is going to stay the same. Okay, with linear combination or elimination, this is where you add your two equations. So 4m and 3m is 7m. Negative 2n and positive 2n, those cancel to become 0. And negative 2 and 30 is 28. If you do everything correctly with linear combination, one of the variables should drop out. So I wanted those n's to drop out. That's why I had them be opposite signs of the same number. Now I can solve. If 7m equals 28, divide by 7, I get m equals 4. Now I can use either equation to solve for n. I'm going to use the first one. So I have 2 times 4 minus n equals negative 1. So 8 minus n equals negative 1. Subtract 8. Negative n equals negative 9. So don't forget that n had a negative in front. If I divide by negative 1, I get n equals positive 9. So my solution is 4, 9. So this is m, n. So 4, 9, that's the only solution that will work in both equations. Now, like before, I want you to check your answer. It's easy to check your answer, so do it. Okay, so 2 times 4 minus 9 equals negative 1. Well, this is 8 minus 9 equals negative 1, so my first equation works. Looking at my second equation, 3 times 4 plus 2 times 9 equals 30. So this gives me 12 plus 18 equals 30, which also checks out. So you always need to go back and check your answer. Again, if you substitute the point and it doesn't work in one of the equations, at least, it means you did something wrong. Okay, we have one more example to do. So look at example, well, one more for linear combination. Okay, so looking at the next example. Again, we want the numbers to match with opposite signs. Now I notice I have positive x, I have positive y, so I don't have opposite signs. So it really doesn't matter which one I pick. Because I eliminated y before, I'm going to eliminate x in this problem, although you could eliminate y. So what I'm saying is I need these coefficients to match, but be opposite signs. So I need to think, what's the lowest common multiple of 6 and 8? What do they both divide evenly into? Well, 8 goes into 8, 16, 24. So 24 is what 6 and 8 both go into. So I'm going to multiply my top equation by 4. That will give me a 24x. And I'm going to multiply the bottom equation by 3, which will give me a 24x. Now I need one of these to be negative, so I'm going to make the first equation negative. So multiplying the top equation by negative 4, I get negative 24x minus 12y equals negative 24. Multiplying my second equation by 3, I get 24x plus 15y equals 36. Now I want to add. I'm going to notice those x's cancel out, which is exactly what I wanted to do. I wanted to eliminate the x's. Now 15y and negative 12y is going to give me positive 3y equals 12. If I divide by 3, I get y equals 4. Now I can use either equation to solve for x. I'm going to use the top equation. So I have 6x plus 3 times 4 equals 6. So 6x plus 12 equals 6. If I subtract 12, I get 6x equals negative 6, and x equals negative 1. So in this case, my solution is negative 1 comma 4. This is the only point that will work in both equations. It's the point of intersection of the two lines. Last thing that we need to do is check that answer. Yes, I'm going to be making sure that you check your answer for every single problem. So on the first one, I have 6 times negative 1 plus 3 times 4 equals 6. So negative 6 add 12 equals 6. Yes, that checks out. Second one, 8 times negative 1 plus 5 times 4 equals 12. So this is negative 8 add 20 equals 12, which also checks out. Okay, so those are the two methods that you should remember, substitution and elimination. There's two special cases that I want to talk about. So looking at this first special case, you can solve using either method. I notice that I have positive 2 and a negative t. So if I multiply this by 2, the bottom equation, then I'm going to have positive 2t and negative 2t. So my top equation stays 2t plus 4v equals 6. My bottom equation with the 2 becomes negative 2t minus 4v equals negative 6. Now let's try adding. We notice those t's cancel, the v's cancel, and the right side equals. So everything cancels. I end up with 0 equals 0. I need to ask myself, is this a true statement? Yes, this is a true statement. So this means that we have infinitely many solutions. Okay, so geometrically, this means that my two lines intersect in infinitely many places. The way that that happens is if you have a line, and then your second equation is just the same line. So in this case, they intersect here, and here, and here, and here, and here, and here, and here. So infinitely many solutions, that just means that you have the same line written twice. Okay, another special case that you may see is this next one. So again, I notice I have positive 2t and negative t. So I'm going to multiply the bottom equation by 2. So my top equation stays the same. My bottom equation is negative 2t minus 4v equals negative 8. Now when I add, I notice the t's cancel, the v's cancel, so the left side is 0. The right side becomes negative 2. So I get 0 equals negative 2. Is this a true statement? Well, no. Unlike the last problem, this is not true. So this means that there is no solution. Okay, so geometrically, that means that my lines do not intersect. If the lines don't intersect, what's true about them? Well, that means that my lines are parallel. Okay, so that was a quick review of solving systems of equations. What I want you to do right now is flip the page. The next page in your packet is where the classwork begins. You need to do problem number 1 for tomorrow. So when you come to class, I'm going to be making sure that you have this page completed and problem 1 of the classwork. Good luck.